Hello and welcome back to Source Decoded. It has been a while. I think the last video we posted, Jared and I committed to posting videos on a regular basis. Well, we both got new jobs and moved our families, so our intentions didn't really quite mesh with reality, but that happens. So as things have been settling, I've been thinking about how to reboot the channel because I really like doing these things and I like the community and the feedback we get on the internet, and I feel like hopefully I'm able to share something valuable back to the internet, which has helped me tremendously. So as I've thought about the many YouTube videos and other kinds of media already out there on the internet, I was thinking about what I could do to contribute in a way that made a difference. There's a lot of people talking about code and a lot of people talking about programming languages, so I really wasn't sure what Source Decoded could be to really contribute to that. Well, I just finished reading a book by Ed Catmull called Creativity Inc. He's the president of Pixar and Disney Animation Studios, and there's a lot of really interesting and insightful things in the book, which I really recommend reading. But one of the things he said that really hit me was he's talking about how it's disappointing that art education is disappearing from schools. He says this is based on the erroneous assumption that teaching art is about learning to draw, when in fact teaching art is about learning to see. And he goes into detail about how artists train themselves to have a different perspective, different view on the world. So I thought, that's it. That's what Source Decoded can really be about, is investigating how to see what's going on in the world of software. It's not just about how you write code. In fact, I really kind of dislike when people say they're aspiring to be a coders or they go to a coding boot camp, because I think code is just the medium. It's not the point of what we do. You wouldn't really say that poetry is about letters or that art is about paper or pencils. The code that we write is important. We need it. It's how we express ourselves. But knowing how to code really doesn't get us very far into becoming good programmers or engineers. So in order to do that, you really need to train your eye, essentially, your mind, about how to see certain patterns and principles and things in software. So that's kind of what the channel, I hope, will be about going forward. I've had good intentions in the past, so, we just kind of have to see where this goes. Anyway, like I said, I've moved. Jared isn't here for this video. We're trying to figure out how we can get back onto a schedule doing videos together, because I think that's really fun and helpful for a lot of people. But I've got a bit of a new setup here. True to Source Decoded tradition, I've got a whiteboard. It just happens to be on my desk, and it's very small, so we'll try to make good use of this. And we're also going to look at some code that I have running on the computer. So we've got it set up so we can do some screen recording. So hopefully that helps. So kicking off this new version of Source Decoded, we're like up to version 3 or something now. Maybe something will stick. I thought, maybe we should just go back to the basics and look at the classic Hello World program and see what we can learn from it. I've gone ahead and written a Hello World program in 4 different languages. I've got Python, JavaScript, Erlang, and then C. And the point of doing this is by looking at the same idea through 4 different lenses. Hopefully we can see what is common, what is different, and learn to pick up some detail that maybe we wouldn't if all we were doing was looking at a Hello World program in just one language like you typically do. So we'll go over to the computer here, and you see I've got all 4 of them up here. Here's Python, C, Erlang, and JavaScript. And right off you notice some obvious differences. Clearly the syntax is different between all of these languages. Python and JavaScript look pretty similar on the surface. Python doesn't use semicolons. JavaScript can use semicolons but doesn't have to. C and Erlang have a lot more lines, and they just look more complicated. Now, there are lots of programming languages, and they all exist because somebody created them to solve a certain set of problems in a particular way. And each of these programming languages is designed around a different idea about how to solve programs, or how to use programs to solve problems. So let's go ahead and run these one by one. We'll start out with JavaScript. There's really not much to this program. If I want to run it, I have a couple of different options. JavaScript runs in Node or in a browser. Probably runs some different places, but we're going to go ahead and run it in Node here. And to do that, I just say, hey, Node, run my hello.js file. And here we go. Hello, world. I am JavaScript. That's pretty straightforward. Let's try Python. Python runs in the Python program, so I just have to say Python hello.py, and I get hello world, I am Python. Pretty straightforward. JavaScript and Python have a lot in common. Put these back up here and compare them. These are both interpreted languages, which means we don't have to compile them, and they just run inside of this host program that is the JavaScript runtime or the Python runtime. JavaScript also happens to run in the browser. In fact, we might as well see what happens when we run it here in a Chrome console. And this isn't going to surprise anyone. We get hello world, I am JavaScript. JavaScript and Python tend to help you out a lot. There's a lot going on behind the scenes when you run any program. And these higher level languages like JavaScript or Python and others are really focused on trying to make it easy for the programmer to just get right to the problem and solve it without having to set up a lot of things and write a lot of what's called boilerplate. So they're really easy. In JavaScript, there is this idea of the global object. In Node, it's called global. In the browser, it's called the window. And it just always exists. And you don't have to worry about it being there. And on the window, or on the global object, there is this thing called console, which has a function called log. And you pretty much can expect that any JavaScript runtime you use has a global object with console, which has log, and it runs. So they've taken care of a lot of the messy setting up stuff for you, making it really easy to just get up and go. Python has what they call built-in functions. In fact, I think I have a list here of built-in Python functions. And these functions are available anywhere. In any Python program, you can depend on these things being there. And print is one of those things. So that's super easy. All you have to do is say print hello world, I am Python, and it happens. Now Erlang is also a high-level language. It's interpreted, so it runs inside of a host program. But it takes a pretty different approach to problem solving than most other languages that people are familiar with. And I chose Erlang on purpose because it's maybe a little less common than languages that you've worked with. In Erlang, modules are very important. In fact, you really can't do anything without making a module. So what we're doing here is declaring we have a module, and we're going to export from this module a function called hello world that takes 0 arguments. And I think it's, maybe cute isn't the right word, I think it's kind of cool that in Erlang, every statement ends with a full stop or a period. I think it was developed in England somewhere, so this would technically be a full stop. And then down here we declare the function, and the function, all it does is say IO fwrite hello Erlang. Now this IO module is apparently available everywhere, and it's got this fwrite function on it. So we don't really have to import that. JavaScript and Python run code top to bottom. And Erlang doesn't really do that. In fact, an Erlang module doesn't have a default entry point as far as I understand. So I can't just say Erlang run hello.url, that won't work. In fact, all that will happen is it'll launch the Erlang environment. Okay, so now we're going to run our Erlang script. And there is actually technically a way to run an Erlang module without getting inside the Erlang environment, but I'm not going to do that today. So I've started Erlang, and now I say, hey, my module, hello world, full stop. And now it's imported my module hello. It just kind of did some magic looking in the directory that I invoked the Erlang environment from. Found this hello module and knows that I exported hello world. I call it without any arguments, so it ran this code. So that's a little different, and I think maybe that, hopefully that informs, that gives you a little more information about how things are handled differently in different programs. It's a lot of time, especially if you use a lot of C-like languages, you end up thinking that everything kind of does everything the same way, and it's helpful to take a different point of view on things. Erlang is actually really cool, and I'm sure we'll use it for more examples of things in the future. So there's Erlang. Now let's look at good old C. Now C is, well, let's get out of here. C is an old language in terms of computers. Certainly there are older languages, but C has been really important and popular for a few different reasons. One is it's really efficient. Unlike the other languages that we've looked at, C is not interpreted, it's compiled, which means you're going to run a program on your source code that generates actual machine and operating system instructions. So there is no host application like Node.js or Python or the Erlang interpreter. It just runs on the computer. And that, at least in the old days, was a guaranteed performance boost. You got way faster execution if you crunched it down into language that the computer could understand, and then the processor just ran it. But because of the way it's built, C doesn't really solve a lot of problems for you. It doesn't do a lot of work for you the way JavaScript or Python would. You have to be very explicit about pretty much everything you do. So if we look at our C program here, we have basically 5 lines of instructions. This include statement, int, main, and then here's the one-liner that we could have done in JavaScript, and then return 0. So what is all of this stuff doing? In this program, pretty much the only thing that C is giving us is this main function. It expects every program to have this entry point called main that returns an integer. And we'll talk about that in a second. Then in this main function, we're just doing 2 things. Printf hello world, and then return 0. Let's go ahead and compile this. We're going to do that with the GCC compiler, hello.c output to hello. And it will run and do its thing. And that is going to generate this hello file. Well, we can execute that directly, and we get hello world from good old C. Now basically nothing in this program aside from the main function is taken for granted. This printf symbol, this function, has to come from somewhere, and it comes from standard IO. If I take that out and then try to compile, the compiler is going to yell at me saying, I don't really know what printf means, but I see it enough that I can pretty much guess. It says, warning, implicitly declaring library function printf with type int. It's saying, you didn't declare this on purpose, so I'm just guessing that what you meant is the one that was in standard IO. So, and it gives me a helpful include the header standard IO. So we'll put that back to make the compiler happy. And then the function has to return an integer because an operating system, when it runs a program to the operating system is basically a function. It has to return a value. And on computer systems, most of them, if if a program ran well, it returns 0. If your program returns a non-zero result, then that's an indication that something went wrong, usually an error of some kind, and you should look into it. So by returning 0 from this main function, the operating system knows everything was cool. Now there is a lot more going on than what we've talked about. We could talk about runtimes and what standard input and standard output actually means, but want to try and keep this video a little bit short, so we'll leave it there. If you have any questions about anything we talked about, please post them in the comments. We'd appreciate your subscription and some thumbs up. And if you've got topics that you would like to learn more about, or that you think we need to learn more about, we've been corrected in the past on things, and I expect that it will happen again. If you're some Erlang ninja and I did something very wrong here, do let us know and we'll cover it in a future video. Anyway, thanks for watching, and I hope you stick around to see more of what Source Decoded has to offer in the future.